problem. Okay, so in this problem, we're trying to combine ammonium and sulfur's MCI. And what we're going to be doing is we're going to be writing the formula and the name. Okay. All right. So you guys should be looking at your paper. You guys shouldn't be talking now. I gave you guys more than enough time to get set up and get ready. Okay. Like I said, the only issue I have in this class is bothering people who want to learn. So if you guys are talking while I'm talking, then I'm going to kick you out. Okay. All right. So let's look for ammonium. So ammonium is a polyatomic ion. So if we go to the common polyatomic ion chart, we're going to look for ammonium, and ammonium is NH4+. Okay. So we're going to write NH4+. Okay, so we have ammonium right here. Now it's telling us we're reacting that with sulfur's MCI. Okay, sulfur's MCI. So if we go to the periodic table, I want you guys to find sulfur, and what we're going to do is we're going to use the pattern that we learned to figure out sulfur's MCI. We said the pattern is 1, 2, 3, no MCI, -3, -2. So sulfur MCI is going to be -2. So we're going to write S2-. And we're going to be putting them together. Okay, so which one do I need more of? Ammonium or sulfur's MCI? Ammonium, because if you look at the charge, sulfur is -2, right? That's too much negative energy. Ammonium only has +1, so we need more ammonium to balance out the sulfur, right? Because if you have somebody in your friend group that's too sad, you need more happy people around them to kind of cheer them up. So we're going to need 2 ammoniums to balance out the -2 on the sulfur. So if we put them next to each other, we're going to write NH4S. Since I use 2 NH4s, I have to put a parentheses around it and put a 2 next to it. Okay, and there you go. This is your formula for the ionic compound. What was that? Put what up real quick? Oh, yeah, it'll be up here. Sorry, old man losing my hearing. Okay. Thank you, I appreciate that. It's because Asians don't raisin. Okay, so so ionic compound is NH4 in parentheses 2 and S. Hey guys, like I say, God's fair. I'm very short and I'm kind of weak and bad at sports, but I'm gonna look young forever. Huh? Thank you. I'm trying. All right, so that's the formula of the ionic compound that's made. Okay, this is the formula. Okay, but we also need to do the name, which is what we learned last time. And so if you guys look at the naming rules, we always write the cation or the positive one first, and then we write the anion, which is negative. So what's the name of the cation here? Yeah, ammonium, it's just right there, and we keep it the same. So the cation is ammonium, so we write ammonium. Are you guys good over there? Why are you throwing pencils, man? Yes, I don't have proof. All right, so our cation is ammonium, and so for our anion, we need to figure out whether it's one element or if it's polyatomic. So if we go to the naming rules, and don't worry, I'll pull that back up. If an anion is only one element, we have to change the ending to IDE. But if it's polyatomic, we keep the name the same. So all the polyatomics we'll talk about in this class are on this chart. We said that the MCI for sulfur is the anion. Do you guys see sulfur's anion up here? No, right? So it's not a polyatomic, which means that our anion is only one element. So we have to change the ending to IDE. And look here, the example has it. S2- is called sulfide. So what we're going to do is we're just going to write sulfide for the anion because S is sulfur and we have to change the ending to IDE since it's only one element. Okay, and there you go. That is the name of your ionic compound. This is the name. Okay, so the formula for this ionic compound is NH4 parentheses 2 S, and the name is ammonium sulfide. All we need to do is write the positive one first and then the negative one second. And so that's pretty much what we learned last time. And then we're going to be finishing up learning how to name things. And then we actually only have one more thing to learn this unit before the test. I know, this unit is short. Okay, so if you guys want to take a look at Canvas, I'll put this back up in a second, but if you guys go on Canvas, I have updated everything for Unit 2, all of the assignments, and our exam is going to be on November 10th. Okay, so yeah, it's a lot of time, about 3 weeks until then. And so we have a couple labs. So we have one lab before then, and then so we just have one real thing to learn before we take the exam. Okay. So just make sure that you guys are following along with the assignments. And if you have any questions, make sure you guys talk to me during independent work time so I can help you guys out. Okay. Alrighty, so let's move on. We're going to take a look at this chart again. So make sure you guys pull this up. We should be all looking at this chart in your sheet protector in front of you. And we're going to be looking at the bottom table again for the naming rules. Now, last time we met, we learned about this rule, and this rule. We said we're going to ignore this rule down here, but this is the one that we're going to be learning, and then we'll be able to name any of the ionic compounds, okay? So this is a cation rule, the positive one, okay? And so up until this point, we've only been looking at cations that have an MCI, but today we're going to be looking at cations that are in this middle section right here, the areas that don't have an MCI. Okay, so iron is an example of one of those cations. Iron can be either +2 or +3. And so if we have a cation that's in the middle of the periodic table here, all we need to do is we need to put the charge in parentheses in front of the name, okay? So if we have iron and the charge is +2, we just put iron, and then in Roman numerals, we put 2. If iron's charge is +3, we put 3 in parentheses in front of it. That's pretty much it. That's the only, and then after that, we just follow the exact same rules, okay? So we'll try one example to get 2 examples together before I get you guys started on the assignment. But I want you guys just to write the, the name for Cu2+, okay? Cu2+. I'll give you guys a second to try that. Cu2+. So go on the periodic table, find the name of Cu, and then I just want you to write the charge in parentheses in front of it. Take a second to do that. Shouldn't take you more than 30 seconds. All right, so what did you guys get for the name of Cu? Sorry guys, I'm hard of hearing. I hear mumbling. What's Cu's name? Copper, thank you. Take copper, and since the charge is +2, we just put 2 in front of it in Roman numerals in parentheses. That's it. So if the molecule we were looking at was this right here, if we had Cu Cl2, then we would write copper 2, and then we would just change the ending from chlorine to chloride. And that will be the name of this molecule right here. Okay, so if the cation is in the middle of the periodic table with no MCI, all we need to do is we just need to put the charge in parentheses in front of it. Yeah, what's up? Chloride is for this one right here, I just changed the ending. So it might be a little bit strange again, but after we do a couple practice problems, hopefully it'll make a little bit more sense. Again, if we have a cation that can have more than one charge, usually the ones in the middle, then all we need to do is put the charge in parentheses in front of it, okay? And we have to do it in Roman numerals, so if you guys don't know Roman numerals, this is 1, this is 2, this is 3, and then sometimes we'll do 4. This is 4. Okay. All righty. You guys ready to go to try some problems? Okay, we're gonna do 4 problems today, just like last time, and then I'll get you guys started on the assignment. Okay. So if you guys feel like you guys can do this on your own, feel free to kind of just ignore me for a little bit, and then you guys can just check your answers afterwards. But for everyone else, we're gonna go through it step by step. Okay, so here we have the cation, which is Au, and then it looks like the charge is +1. So I'm gonna go on the periodic table and look for Au. So if you look for Au, you should see that it's gold. Okay, everyone's favorite. Okay, so we're gonna write gold. So Au's name is gold. And since Au is in the middle of the periodic table, we need to put the charge in parentheses in front of it. What's the charge on this gold ion? 1, yeah, so we just write Roman numeral 1. That's it. Okay, next we have chlorine's MCI. We just talked about chlorine's MCI. We said chlorine's MCI is Cl-. And so if we put Au and Cl together, would they be able to balance each other out? Yeah, it's +1 and -1. So we can just put them next to each other. And there you go. This is your formula. Now, if we take a look at the anion, the negative one, is it one element or is it polyatomic? Guys, you guys have to be confident. Everyone says the right answer. Is it one element or is it polyatomic? It's one element. Thank you. Chlorine is one element because if you guys look at the polyatomic chart, do you see chlorine on this? No, there's no chlorine, so it's not polyatomic. So it's going to be one element, and if it's one element, we have to change the ending to IDE. So it's going to be chloride. And there you go. That's the name. So the name of this chemical right here, AuCl, is going to be gold 1 chloride. Okay? That's pretty much how you do it. It's basically the same thing we did last time. All we do is we put the parentheses in the front based on the charge of the cation now. Okay. All right, so I'm going to give you guys maybe about 2 minutes. You can work with the person next to you and you could find the formula and the name for the ionic compound that's made of Ti4+ and cyanide. Okay, and if you guys forgot, for Roman numerals, this is 1, this is 2, this is 3, and this is 4. Okay, so if you guys need that, feel free to use it, but I'll give you guys 2 minutes to try that out. We'll go over it, and then we'll move on to the last 2 problems for today. Are you all right? Well, at least you know. Self-aware. All right, maybe just a minute to finish that up, guys, and then we'll go over it together. Alrighty, guys, so let's go over this together, and then we'll move on to the last two problems for today. Okay, so here we have Ti4+, and so we have the charge for the cation. So we have Ti4+. Okay, did you guys get the name for Ti? Yeah, titanium. You guys should be probably familiar with that, titanium. So I'm just going to write the name titanium underneath it, just so we have it in our back pocket. Titanium. Okay, now we're going to look for cyanide. So if we go to our polyatomic chart, you should be able to find cyanide. Cyanide is Cn, and it's -1. So we're going to write Cn -1. Okay, so cyanide is Cn -1. Now, which one do I need more of, titanium or cyanide? Yeah, cyanide, because it's -1. Specifically, how many cyanide do I need in total? 4, good. We need 4. That way we can have 4 of them and they can balance out the titanium's +4. So titanium is like that friend that's super duper happy and kind of needs some sad people around them to bring them down to earth. Because nobody likes people that are too happy, especially in the mornings. Okay, so we're just going to write Ti and Cn next to each other. We used 4 cyanide, so we're going to put it in parentheses and put a 4 behind it. And there you go. That is your formula. Okay, so our formula is going to be Ti and then in parentheses Cn with a 4 on the outside. Okay. Any questions about the formula? All right, now we just need to name it and then we will be all done. So the cation, the positive one, we said is titanium, so we just write titanium. But since titanium is in the middle of the periodic table, we need to put the charge in parentheses. So we just put a 4 in the middle. And we have to do it in Roman numerals, so 4. Okay, and then for the anion, we need to figure out if this is one element or polyatomic. Okay, this one's pretty easy. We literally just looked at the polyatomic chart. So since it's polyatomic, we don't need to change the name at all. So there you go. That is your name. The name is titanium 4 cyanide. This is the name of this chemical right here. Okay. So if you guys were able to get that on your own, good job. It actually does not get much harder than this for today. As long as you remember to put the parentheses for compound or cations that are in the middle of the periodic table, you should be good. Okay. All right, so we have 2 more examples that we're going to do before I get you guys started on the assignment. And these 2 examples are the same thing we did last time. We're going to be going backwards. So for the next 2 examples, I'm going to give you guys the name, and then you got to find the formula using the name. Okay, but these parentheses actually make it easier than last time. All right, so let's get started with those. And again, if you guys feel confident doing this on your own, you can kind of ignore me and just check your answers at the end. We'll do the first one together, and I'll let you guys try the second one on your own, okay? So the first compound is iron 3 nitrate. So I'm just going to look for iron on the periodic table. Iron is Fe, so I'm going to write Fe. So iron is Fe. All right, so according to the name, what is the charge on iron? Yeah, 3+. There's a 3. So it's going to be 3+. There you go. So it's a lot easier than last time, because last time you kind of had to figure out what it was. But if there's a parentheses, you just write it down, and that's the charge on it. Okay. All right, let's look for nitrate now. Nitrate is the anion or the negative one. So we're going to go to the polyatomic chart. And you should look for nitrate, which is NO3 minus. So I'm just going to copy down nitrate, which is going to be NO3 minus. Okay, and we're going to be putting these two guys together. Okay, which one do I need more of, iron or nitrate? Nitrate, it's going to, because it's -1, so you need 3 of them. And so if I wanted to write the formula, I just write iron and nitrate next to each other. But since I use 3 nitrates, I have to put it in parentheses with 3 behind it. And there you go. That is your formula. Okay, so this is the name. So iron 3 nitrate looks like this. This is going to be iron 3 nitrate. Not too bad. All right, so I'll give you guys 2 minutes to try the next one on your own. You have copper 2 chloride, and that's going to be the final example. Try it out. Try to get the formula. After that, we will. I'll get you guys started on your assignment for today. All right, just another minute, and then we will go over it. Alrighty, guys. So if you guys are finishing up, you feel free to finish up while I'm going over it on the screen. But just make sure to check your answer at the very end. Okay. So here we have copper 2 chloride. So what I'm going to do is go on the periodic table and look for copper. If you look for copper, copper is Cu. Okay, so we're going to write Cu. So copper is Cu. And since there's a 2, that means that this copper is going to have a charge of +2. Okay. Next one is chloride. So chloride is going to be the ion name for chlorine. And earlier we said chlorine is -1, so we're just going to put a minus sign. And since copper is +2 and chlorine is -1, we're going to need 2 chloride ions to balance it out. And so if we put them next to each other, we should get CuCl2. There you go. That is your answer. Okay, so copper 2 chloride looks like that. So hopefully you are able to get that one on your own. If not, you'll have a lot of time to practice. And I do have the answer key for your assignment if you guys want to check your answers at any point. Okay? All right, so just to remind you guys, this lecture has been recorded and it will be on Canvas. If you guys need a refresher or if you you missed something, But other than that, I'll give you guys the rest of the class period to work on your assignment and let me know if you guys have any questions or if you want to check your answer.